All right, it is now 8:05 on the Pacific Coast, so we're going to go ahead and get started. Hello and welcome to a special session of Seabird University on the new HydroCAT EP V2. My name is Natalie Zielinski, and I'm a product manager at Seabird Scientific. Coming from a history of science where I used Seabird equipment in my own fieldwork, I'm excited to speak to you today about our newest fully integrated system, the HydroCAT EP V2. Please advance the slide. With its many available custom configurations, the HydroCAT EP is an ideal solution for work related to water quality monitoring, research, or site characterization, just to name a few, and can be deployed in inland waterways and lakes to the coastal and near-shore ocean. The HydroCAT utilizes proven low drift temperature and conductivity technology found in all Seabird CTDs, offering the highest accuracy available so you can be confident in your data. The swappable design of the pH sensor means a quicker turnaround after a laboratory or field calibration of up to 3 months of hands-off, waste-free pH measurements. As the next generation instrument in the HydroCAT EP line, the V2 design includes a new flushing port at the pH sensor connector to mitigate against corrosion in seawater applications. Additionally, this robust system with improved durability means low-risk data collection in the toughest biofouled and tidal environments. Optional configurations with pressure, optical dissolved oxygen, chlorophyll, turbidity also mean you can order a system that's unique to your needs. Today, Greg Akita, our Senior Content Development Manager and Instrument Trainer and Expert, will walk you through our recommended best practices for operation, storage, and maintenance of the HydroCAT EP V2. We're here to train you, so please don't hesitate to ask questions and share your background on your program goals for an open discussion on any specific guidance you're looking for. Our chat feature is available, and we also have a Q&A section. With that, please welcome Greg Akita.
Great, thanks, Natalie. Let's see. So, hi, everybody. I'm Greg Akita. I'm going to train you today on the HydroCAT EP V2. So the purpose of this Seabird University session is to introduce you to the instrument and really give you the knowledge that you need to take this thing out of the box, talk to it with software, know what kind of maintenance you need to do, get it into the water, get it out of the water, and upload and process your data. We have some training videos that we've filmed that you can access via our YouTube channel to see how to do certain maintenance tasks in a little bit more depth than we're going to cover today. But for the most part, the goal of today's training is to teach you how to use this instrument that we've got right here. So this is it. This is the HydroCAT EP V2. For those of you that are familiar with the HydroCAT EP V1, you might see that these are almost identical to one another. It's actually pretty hard to tell one apart, but inside of the HydroCAT EP V2, we've made a handful of enhancements and have done some changes to the pH sensor on the V2. So it's really an improved instrument over the V1, even though it looks pretty similar. So I'm going to put this one away. So, as Natalie mentioned, this is a multi-parameter instrument. It's based off of the SBE 37 MicroCat moored CTD line. So it has temperature and conductivity, like the rest of the Seabird CTDs, as well as optional pressure, dissolved oxygen, chlorophyll, and turbidity. What's special about the HydroCAT EP is it has an integrated pH sensor. This guy right here, we'll talk about that in more depth a little bit later. This is the field swappable pH sensor. And for those of you familiar with the V1, this one might look a little bit different. It's got this brass plate on the top that has some differences in how it connects to the HydroCAT EP V2 for better field performance. So we're going to talk about that in a little bit. But overall, this is a great fully integrated multi-parameter instrument. It has a RS-232 and SDI-12 interface. Today, we're going to be talking to it via RS-232, but SDI-12 works just like the HydroCAT EP V1 did and most other SDI-12 instruments. This can be deployed with internal batteries. We've kind of changed the battery pack a little bit. and as well as with external power. If you're using SDI-12, you're required to use external power. So the battery pack that goes into the HydroCAT EP V2 is this pack right here. This uses a set of lithium AA batteries. Do not put alkaline batteries in here. These lithium cells are, I think, 3.6 volt cells. A typical alkaline AA cell is 1.5 volts. So if you fill this up with batteries, alkaline batteries, and put it into the HydroCAT, you're not going to be able to collect any data. If you've seen this before, or think you've seen this before, this is actually the exact same battery pack that goes into SBE 37s. So that's pretty nice. If you already have a fleet of SBE 37s, your battery packs are completely swappable. So it's nice to have a couple spares on hand just in case. So speaking of the battery pack, I'm just going to give you a quick rundown on how to replace the battery pack on the HydroCAT EP V2. So currently, this unit has a pack. If we ship this to you, we have to remove the battery packs for shipping. So you might receive one of these empty and then a little cardboard box filled with individual AA cells. That is one of the first things that you'll want to do unless you're using SDI-12. So replacing the batteries on the HydroCAT EP is very similar to replacing batteries on an SBE 37. If you've done that before, we have these two screws on the sides here. I'm going to remove these. And we have this one screw on the top. You do not actually need to remove that. If you look closely, this screw is actually sitting on top of this little ramp. And now that allows you to twist that screw. It goes up the ramp, it backs off the end cap, and you can very carefully remove it. The end cap is connected via this little Molex connector right here, so gently remove that. Set this aside in a spot where it's not going to contact any lint, dust, or debris. And then we can see we have the battery pack inside of the instrument. Now, to access that, we need to take another hex key. And there is a tiny captured screw in here. We're just going to back that out. And then you can grab the handle of your battery pack. Make sure you have fully loosened the screw. And then pull it straight out. Now, at this point, you can take a spare battery pack. If you've got one, you can open this up, replace the individual cells, and install it back into your HydroCAT EP. I'm just going to put this one back in here because I know that these batteries are good. Very easy process to replace the batteries on your HydroCAT EP. Okay, so I'm just going to tighten that. Take this. I'm going to make sure that I'm reinstalling this Molex connector and it's making a good connection. Otherwise, we won't be able to talk to the instrument through this bulkhead connector. Put that back into place and then reinstall these two screws. Word of warning, we put blue moly on these screws, so you might need to wash your hands afterwards. And there, super easy to replace the batteries on the HydroCAT EP V2. Exactly the same process as the V1. Okay, so really quickly, I want to take a look at the specs and calibration of this instrument. So as mentioned before, multi-parameter instrument, lots of different sensors on here. You have your base conductivity pressure, conductivity temperature pressure that you have with other Seabird CTDs. This also has an optical dissolved oxygen sensor, the SBE63. So this has the same specs as the SBE63 that you have on your 37 SMP ODOs from Seabird. Maybe you have an SBE63 installed on a 16 plus V2 moored CTD, exact same sensor, exact same specs. This has a special pH sensor, this guy right here. And so this is a glass electrode pH sensor. This is different from sensors like the CFET V2 and the CFOX V2. in that it uses a different kind of sensing technology. As such, the accuracy of this is 0.1 pH, and it retains its stability of 0.1 pH for approximately 90 days. So that's something to keep in mind. We also have turbidity and chlorophyll. So that is this sensor right here. We call this the HCO. This is effectively a miniaturization of the ECO optical sensor, very similar to the ECO FLNTU from Seabird. So optical sensor measuring turbidity and chlorophyll. When you have the full package, you're measuring a lot of different parameters. You can do a lot of interesting analysis with all those different parameters, and they're all fully integrated. So your samples are lined up with one another. You don't have to get a bunch of modular sensors, connect them to a single CTD, and hope that everything is working. You can just get this, put it in the water, and know that it's going to work out. So speaking of the pH sensor, all of the sensors, except for the pH sensor, have a 1-year factory calibration. This is pretty standard for Seabird CTDs, where we recommend recalibrating your instrument every year in our world-class calibration bats to really maintain the optimal spec of these sensors. However, the pH sensor, given that it is using this glass electrode technology, requires this 90-day field calibration. And so these are field swappable. You can have multiple of these, calibrate them in the lab, go out to the field, go out to your HydroCAT, and then replace them. It's a pretty quick process that I will demonstrate today. That being said, your pH sensor is really the limiting factor of your sensor calibration, with that 90-day, approximately 3 months, versus the 1-year factory calibration of everything else. That being said, in my experience, a lot of these glass electrode pH sensors are typically need to be recalibrated every week or every 2 weeks to maintain their spec. We've done a lot of work and research into making sure that this particular sensor can be used in the field for 90 days and retain that 0.1 pH accuracy. Something else that's special about the HydroCAT EP is it has this pumped flow path. Pumped flow is a pretty standard thing that Seabird CTDs have going for them. This flow path is pretty similar to the 37 SMP ODO MicroCAT CTD, if you're familiar with that, where by using an integrated pump that is flushing water past several sensors, we get really good response time from these sensors and really good alignment of our samples. Because your pH sensor, your temperature sensor, your dissolved oxygen sensor, and your conductivity sensor are all plumbed together, you know that they're all sampling the same water. You know that when your instrument is sampling, it is actually pulling in a new sample of water. You don't have to rely on natural flushing or hope that currents are going to replace the water. You can guarantee that the pump is going to pull in a new sample for your HydroCAT. And so, as I mentioned, temperature, conductivity, pH, and dissolved oxygen are all contained within this pumped flow path, and that's aligning your samples, improving sensor response. So the pH module, this is one of the more special things about the HydroCAT EP family, and we've redesigned the pH module for the HydroCAT EP V2. As mentioned before, this is a modular field swappable sensor. You can calibrate it in the field or in the lab if you have multiples of these. That being said, because it is a glass electrode sensor, it has to be stored in potassium chloride in this soaker block. So what you can do, calibrate this in the lab, store it in the soaker block, take it out to the field, and install it in your HydroCAT EP that's currently deployed. If you do not store this in potassium chloride solution, then your sensor is going to drift relatively quickly. If it dries out, you might have to do some maintenance that we'll talk about later. And then also, it's possible that if this is left to dry for a long period of time, it's going to need to be completely replaced. So always store it in soaker block. We have a video demonstrating how to store your pH sensor. I'll show you how to do that today, and I'll show you how to install your pH sensor. But as I mentioned before, pH, limiting factor of HydroCAT EP deployment length. This has a 90-day calibration as opposed to that 1-year calibration. Keep that in mind. It's possible that depending on your battery endurance, your sample interval, you might not even be getting 90 days out of your deployment anyway. And just remember that this sensor after 90 days may or may not be hitting the mark for what you're looking for. So we recommend 90-day calibration. When you are installing the sensor, it requires care. So this has a small connector on the HydroCAT EP body, as you can see on the top picture on the right side of the slide. That connector is liable to getting seawater into it, which can corrode the pins on the female connector on the HydroCAT body and the male connector on your pH sensor. So we've built some fail-safes into that to prevent seawater from contacting the pins. On top of that, we have now these 2 screws that screw into the HydroCAT EP body. Do not over-tighten these. They're pretty small. You're liable to damage your instrument. The installation process is simple, but must be done correctly. Comparing this to the pH module on the HydroCAT EP V1, if we put them next to each other, they look pretty similar. Visually, this plate on the top is really the only major difference. That being said, the previous pH module and the previous HydroCAT EP, they screwed in with only 1 screw. There's only 1 screw that connects this pH sensor into this spot on the HydroCAT EP V1. Whereas now we have 2 screws for extra security. That's to ensure that you get a really strong connection, get a good seal on that connector, and your pH sensor is going to last for the entire deployment. So keep that in mind. That's one of the primary differences between the HydroCAT EP V1 and the V2. Okay, so now let's take a look on how to actually install the pH sensor. I have my HydroCAT EP V2 right here. I have my pH sensor. I'm going to switch my camera to this view so you can get a closer look. Okay. Looks pretty good. Okay, so as mentioned before, the HydroCAT EP V2 now has 2 screws connecting the pH sensor to the HydroCAT EP. So we are going to take our Allen key, remove the dummy block that's currently taking the place of the pH sensor. And when I do this, I like to loosen both screws alternatively a little bit at a time, maybe a couple of turns, just so that it's not canting to one side. And then when I'm fully out, you can just pull this straight out, just like that. Okay, so now we can see the female connector inside of the HydroCAT EP. I might need a little bit of light here. So we can see, hopefully, kind of hard with this camera angle, the connector inside of the HydroCAT EP, as well as the part of the flow path that connects to the HydroCAT. So next thing we're going to do is take our modular pH sensor, carefully take this out of the soaker block, and then install it into the HydroCAT EP. So this soaker block has a tiny reservoir inside of here that is soaking the electrode in potassium chloride solution. This block has this screw right here where you can empty the potassium chloride or fill it up. So what I recommend doing first is removing this little screw. And sometimes get stuck. And then pouring out any solution that's currently inside of here. Okay, so we remove that screw. We can see there's a tiny O-ring inside. I'm just going to dump this out into this little bucket I've got here. Okay, so removing that helps to prevent any of this solution from contacting the pins on the connector when you take it out. If you're careful, you don't necessarily have to do that every time, but I would recommend doing it. It's a very tiny amount of solution, so you're not really wasting that much. And then I'm going to loosen the 2 screws on the pH sensor a little bit at a time. Until they are no longer connected to the soaker block. I'm going to put this down and pull this straight up. Pulling it straight up prevents any of the solution that's inside of the reservoir from spilling over to the connector. Now, before I install, I like to just take a look at my sensor. This up to the camera. So we have our sensing elements on this side, and we have our connector here, which is protected by this O-ring right here. I'm just looking for any kind of debris that could be bridging this O-ring that might compromise the seal. This one looks pretty good to me, and I'm looking to make sure that there's not any of this KCl solution on any of these pins. These pins look pretty dry, so I think that this one is ready to go. Okay, now I'm just going to install this into the slot where I removed the dummy plug. I'm going to put it in, line it up, push it in until I can feel the connector go into the HydroCAT EP. And then I'm going to slowly tighten these, again, doing them a little bit at a time, alternating between each one. Now, I like to tighten this not by holding this angle on my Allen key, but to sort of spin it, just gripping it with my fingers. That's going to help prevent me from over tightening this. Once I can't tighten that anymore, I'm going to very carefully ensure that it's tight, not over torquing this. Get it to the point, making sure that I'm not over tightening this. And then I'm going to take this and just see if it moves back and forth too much, if it feels loose. This one feels tight. It's not moving back and forth. It feels as though it's tightly seated within the HydroCAT EP. And then now we have our pH sensor fully installed into our HydroCAT, and it's ready to sample. Now recall that these electrodes are not meant to dry out. So while it's in the HydroCAT EP right now, it's actively drying out. We have some time. It's wet. It's going to take a while for it to completely dry. But anytime you are leaving the HydroCAT EP out of water, say for more than an hour or so, I would recommend reinstalling your pH sensor back into the soaker block and making sure that you have KCl solution in the soaker block. But for now, we've got time. So this is looking pretty good. Okay. Switching camera back. Okay, so that's how you install the pH module. This is great. We're going to put this HydroCAT into some water pretty soon. So we can leave it as is. Going to clean out the work area. We'll talk about a couple more features of the HydroCAT EP, and then we'll put it in some water. So I would like to talk about the Antifouling Guard on the instruments. That is this guard you can see on the right. Currently on my instrument, I have this sticker on it. This is a brand new HydroCAT EP. And so we ship it with this sticker covering up the holes for the intake and the exhaust for the flow path to prevent these anti-fouling cartridges from leaching any toxic chemicals out. And so always remember to take this sticker off before you deploy it, otherwise you won't get water into your system. So that's what I'm going to do first thing, just pull off the sticker. And so right here, I have my anti-fouling guard. This is a copper guard that houses 2 cartridges of TBTO anti-fouling chemicals. These are the exact same things we used in the SBE37s, SBE16s, SBE19s, etc. And they prevent biological growth inside of the flow path. And so what happens is you have one cartridge that's covering up the intake of the flow path and one cartridge that's covering up the exhaust of the flow path. And so this flow path, as we saw before, shaped like a U, any water that's inside of here is being exposed to TBTO chemicals, preventing any biological growth from coating your oxygen sensor, your conductivity cell, your pH sensor, etc. This is really going to extend the deployment lifetime of your instrument significantly. When these are spent, or if you deploy this without anti-fouling cartridges, you'll still get good data, but if you're in a high biofouling area, your results are going to vary. So highly recommend deploying it. It's kind of hard to tell exactly how spent a given antifouling cartridge is. If you look at this picture on the left side, we have used antifouling cartridges where they have sort of varying looks when they are spent. But on the right side, we have brand new antifouling cartridges. It's hard to determine these visually. We recommend replacing them about every year or so. They should last for the entirety of your deployment. Just keep in mind that if you start to see low conductivity or low dissolved oxygen, it could be biofouling in your instrument, and these cartridges need to be replaced. When you're handling these outside of the antifouling guard, always wear safety goggles and always wear gloves. They are toxic chemicals. So I'm actually going to take off the antifouling guard on this instrument before I put it into my tank of water, just so I don't get any trace amounts of TBTO into the water. So you can remove this pretty easily. So again, we're taking an Allen key, and you're going to put it into these top two holes here. So I'm just going to loosen each side. These screws are fully contained inside of the antifouling guard. Once they are completely loose, this comes right off. And so if you look inside of here, this might be kind of hard to see, but there's these two holes that houses the antifouling chemicals, or the cartridges. And if you need to replace those, you can remove this screw right here. This plastic piece comes right off, and then you can replace it with new cartridges, shown in the picture on the bottom right. So now that this is off, we can see that we have these two hose barbs right here. These are the intake and exhaust of our HydroCAT EP. This is intake, this is exhaust. And this kind of illustrates the flow path. You can't really see it with the cell guard in place, but the flow path sucks in water here, goes down, or actually I might have that backwards, sucks in water here, goes past your thermistor, the temperature sensor, goes through your conductivity cell, around dissolved oxygen sensor, back up past the pH sensor, and out the HydroCAT EP. And so for certain maintenance procedures, cleaning, flushing, pH calibration, conductivity checks, you're going to need to remove the antifouling guard so that you can attach Tygon tubing to these two hose barbs. We'll see that momentarily. Okay, so speaking of pH calibration, conductivity checks, cleaning, etc., the way you're going to do that is with the software UCI 2.0. If you're using a HydroCAT EP V1, you probably have UCI 1 point something installed on your computer. We've released a new version of UCI to work with the HydroCAT EP V2. So go to our website and download that. If you're using the HydroCAT EP V2, still works with the HydroCAT EP V1. The software also works with the CFET V2 and the Suna V2. So UCI RS-232 interface, default baud rate of these instruments is 19200. And this is the software you're going to use to change settings, check your sensors to see if they're still within spec, calibrate your pH sensor, and set your instrument up for deployment with the built-in deployment wizard. This is a GUI, so there's buttons to press. Everything is kind of handled for you, but it also has a built-in terminal program, so you can send commands to this instrument just as you would to a microcat in CTerm. You can also use TerraTerm, PuTTY, etc., if you prefer to use a terminal. So let's go ahead and connect our HydroCAT EP to UCI, take a look at the settings in there, and see what we can do with the software. So first thing I'm going to do is take my cable here. This cable is what we'll use to connect to the HydroCAT EP V2. I have it connected to a USB serial adapter. And the HydroCAT EP has a 6-pin connector. So I'll take off the dummy plug. Install the data cable. And connect to UCI. So if this is your first time firing up UCI, this is what it's going to look like. On the left here, you have this UCI dashboard. And so what we're going to do is click on this connect button. As mentioned before, UCI connects to multiple different instruments. And so what you'll want to do is choose the instrument type that you're connecting to, in this case, a HydroCAT EP. Choose the baud rate. Default baud rate is 19200, but if you don't know or if your instrument is not connecting, you have the option to click this box to try all baud rates. If someone has changed the baud rate on your instrument and you weren't aware, you can do this and it will connect. Now, I know that my USB serial adapter is connected to COM port 6, so I'm going to click on Connect. When you do that, the UCI dashboard here is going to change to the HydroCAT EP dashboard. And when we are connected, this connection mode will turn to Setup and will turn green. So we know that we're successfully connected to our HydroCAT EP. We picked the right COM port, we have the right baud rate, our cable works, the instrument has power. Because this is green and these buttons are now available to click. There's a lot of stuff you can do within UCI. So on the left, we have our dashboard where you can click on buttons, change settings, run sensor checks, etc. And then on the right side, we have our time series. UCI can work as sort of a benchtop data logger. So what we can do is click on the start button here after changing your settings, getting it ready for deployment. And then any data that the HydroCAT EP outputs via RS-232 is going to land in this time series window of UCI. Also, when you upload a data file from your HydroCAT EP, that'll be in the form of a CSV file. That data can be displayed in the time series of your HydroCAT here. It's a good way to just visually check your data, see if things are within range, see if the amount of data you have in here is expected. Word of warning, if you have thousands upon thousands of samples in your instrument's memory, it can take a while to actually populate these data. So keep that in mind if you're in a rush. In addition to the time series, the dashboard, we also have a variety of displays. In this view, you can pick what you're looking at in the output instrument console, processing console, application console. I like having the real-time display. This is just going to tell you the value and the units of the data that's coming from the HydroCAT EP when you're logging in real time. And then also the data acquisition monitor is valuable as well. So for the most part, what most people will be using within UCI are the HydroCAT EP Settings and the Deployment Wizard. This is just a quick and easy way to configure your instrument for your particular deployment. So I just clicked on the HydroCAT EP Settings button. This window pops up, and you can see we have a few different options. Output format allows us to modify the format that the instrument is outputting in real time. So when we click on this, we can pick our units for temperature, conductivity, and oxygen. And we can also choose which parameters we want to output, say, to a data logger or to UCI. And so currently it's configured to output temperature. Let's turn it to output conductivity, oxygen, pH, chlorophyll, turbidity. And then you also have your derived parameters, salinity, sound velocity, specific conductivity, oxygen saturation, derived from the raw data you're getting from your temperature, conductivity, and pressure sensors. I also like sample number. So this is how you can modify that. Now, when I change the output format, we can see that this is the format and it now has sample number, conductivity, which wasn't there before. In the data window, we can set our sample interval. Now, your sample interval is typically anywhere between 6 seconds and I don't know the maximum interval actually, but that's also going to be dependent on the pumping time for your instrument. So I think currently my pump time is too long. So I can't do a sample interval of 6 seconds, but I can do a sample interval of say 120 seconds, 2 minutes. You can choose the option to transmit data in real time. Note that doing so will consume a little bit more power. So you can toggle this on and off. If you're only deploying this login data to the internal memory, I would recommend turning this off just to save some battery life, but it's up to you. If you're sending data to a data logger, definitely make sure that this is turned on. And now my HydroCAT EP right here does not actually have a pressure sensor. When it doesn't have that, you want to type in a reference pressure here so that the HydroCAT knows approximately what pressure it's deployed at in order to use that value to calculate things like sound velocity, which is based on the temperature, conductivity, and pressure of your particular instrument. So in this case, I don't know, we're deploying it at maybe 10 meters, say 10 decibars is just fine. For pumping, this works very similar to other Seabird CTDs, if you're familiar. We have what's called a minimum conductivity frequency that allows the pump to turn on. So in air, your conductivity sensor is measuring 0 conductivity. The raw data from that sensor for 0 conductivity is going to be something like 2500 hertz. That's just what the conductivity sensor is outputting when it's not measuring any salt water or anything. We don't want this pump to run in air. Doing so will damage the impeller on the pump. So we have this setting called the minimum conductivity frequency to tell the instrument, hey, if you're not meeting this minimum frequency right here, that tells me that you are not in water, therefore do not turn on the pump. So even if your instrument is logging, if your conductivity sensor is not outputting a value that is higher than this setting, your pump is not going to turn on. It's a fail-safe to prevent your pump from running after you pull it out of the water, but forget to tell it to stop sampling so that you don't damage your hardware. Now, if you're doing autonomous sampling, you also have a pre-flush duration. This is meant to just get any bubbles out of the plumbing and then really get new, fresh water into your instruments before it starts sampling autonomously. So by default, this is 300 seconds. When you start a, say, delayed sampling autonomously, your HydroCAT EP is going to meet the time when it's programmed to start sampling, flush for 300 seconds, and then start the sampling routine. You can change this more or less depending on your application. And you can also schedule that pre-flush based on when you plan to deploy your instruments. And then finally, we have the baud rate. Default is 19200. I recommend just leaving it at this unless you're deploying your HydroCAT EP on a system with maybe a really long RS-232 cable where you need to turn down the baud rate in order to get your data. 19200, it's pretty reliable. So, okay, I didn't really change any settings here besides the output format. I'm going to click apply, and my settings are now programmed into my HydroCAT EP. So that's HydroCAT EP Settings from within UCI. That's just one of many options we have here. One thing I also like is the command terminal. So when you click on that, you're going to have this little window here that is pretty similar to just a basic terminal software. And this is where you can send terminal commands directly to the instruments if that is more your speed. So we can send things like the DS command to get the status. That's going to give us sort of a full rundown of battery voltage of our instruments, what parameters we are outputting, how many samples we have in the memory, how much space we have for sampling, and then other valuable information like our serial number, the current date and time of the instruments, and our minimum conductivity frequency. There's a list of commands at the end of the HydroCAT EP manual. I recommend looking at that to learn what kind of stuff you can do. And because I installed a pH sensor, I'm just going to try this, make sure everything's cool. You can send the resync command, and that's going to make sure that your HydroCAT is properly talking to all of the sensors installed on it. That is the SBE63, the HCO optical sensor, chlorophyll and turbidity, and your pH sensor. When I install a new pH sensor or maybe replace the pH sensor, I like to just send this resync command to ensure that, my HydroCAT sees and is listening to all the sensors on my instrument, including this pH sensor that I recently installed. Okay, so command terminal, all good to go. Now, we don't have time to do the full pH calibration process here. I'll talk about it when we're doing the cleaning process. It's very similar, but again, 90-day calibration stability for this pH sensor. So this is where you would do it. You would click on the pH calibration button here. This window would pop up. Eventually, it might be elsewhere on my computer. And basically, it's going to walk you through the process of calibrating your pH sensor with pH 4, pH 7, and pH 10 buffer solution. It's a pretty straightforward process. That being said, you want to make sure you're doing it correctly and using fresh colorless buffer solutions while calibrating your pH sensor to ensure that when you deploy your instrument out in the field, your pH sensor is properly calibrated, that you can get that full 90-day deployment. It's going to get that 0.1 pH accuracy while it's out in the water. And you do it from within UCI. Now we can do things like a conductivity check to check the conductivity sensor by putting a conductivity standard solution into the flow path. We can do a temperature check when this is installed in water, just to make sure that it's meeting the expected temperature that we expect to see, and also is remaining stable while it's deployed. And then you can run an optics check with the optics check cap that you can get with your HydroCAT EP. That's a little cap that you put onto your HCO optical sensor that's going to output some expected data. Note that this optics check is temperature dependent, so try to do it at around 22 degrees Celsius if you can. So that's kind of how you just make sure your sensor or your instrument is ready to go. Your sensors are responding as expected, and your HydroCAT EP is ready for deployment. Okay, and then we also have what's called the deployment wizard. When I click on this, and it might be buried in my software, here we go. This is just a basic wizard that after you step through this, your HydroCAT EP will be ready to put into the water. So this is a great step to do before you deploy your instruments. So for instance, I'm setting it up for autonomous sampling based on a pre-programmed sample interval. I'll click next. I'll set those parameters. So say I wanted to start next week on the 15th at 16:56. That's fine. 4:56 UTC. Note that this is UTC time. Compare that to the current instrument time to make sure that this is actually the date and time that you want to set it to. And then I can change settings similar to what we saw in the HydroCAT EP settings. I can configure it to transmit data in real time. I can change my output format just as we did before. In this case, say I'm deploying this only sampling data on the instrument memory. So I want to turn this off because I want to save a little bit of power and I'm not sending data to a data logger. Pump setup, just as we saw before, minimum conductivity frequency and the pre-flush duration. If we want to synchronize the clock to your computer, I did this recently, so it's pretty close. Just click on this button. And then also, if you want to start fresh, you want to delete all the samples currently on the memory, make the entire memory available for this deployment, and also delete any event counters, delete the event counter. If something happened, like a lost power or something, it's going to write just a note into the event counter. If you want to start fresh, you can click on this. It will delete everything currently written into the event counter, so you know that any errors that pop up are new errors for this deployment. That helps with troubleshooting. So then when you do that, this little window is going to say, hey, by the way, you're deleting all the data on your memory. Make sure that's actually what you want to do before you proceed. So say yes. And then this is a calculator for your battery endurance. Based on your sample interval, whether or not you're transmitting data in real time, the sensors that you have installed on this, this is just going to give you a conservative estimate for how long your instrument is going to last. So 900 seconds gets us approximately 126 days. 200 seconds gets us significantly less than that. So this is a good way to get a sense for how long you can leave your instrument in the water. Remember, you want to replace your pH sensor every 90 days anyway. So if you are doing a 900-second interval, you might consider changing that to something shorter. So the battery endurance is approximately 90 days. So you can go visit your instrument, replace the battery pack, replace the pH sensor at the same time in a single visit. That's a good way to be efficient. Note that this calculation is based on a full battery pack. So if you have used batteries in this, your UCI is not going to know that. It's not going to know that the battery pack does not have full capacity. It also doesn't know if you're applying external power to the instrument. It's just assuming you're using a brand new set of batteries here. So keep that in mind. And then finally, once you're done, you can create what's called a deployment report that has all of the settings you deployed for your HydroCAT EP. So choose a directory where you want to save that. You can name the file. I'm just going to leave it as default. If there's a file in there, you can overwrite that and then click on this to view the report when it's done. When I click on the finish button, it's going to send all those settings to the HydroCAT EP, get everything configured, ready for the deployments, and then it's going to spit out a deployment report. And now this is just a basic PDF file. It tells you who the operator was, serial number of your instruments, how long you should expect this to last, and then all of the settings of your HydroCATs, as well as the calibration coefficients for your instruments. These are helpful to have. I would recommend making a deployment report before each deployment, just so you know if something went wrong. Is it because we made a mistake during the deployment wizard? Did we set it to actually sample every 120 seconds instead of 900 seconds? That would explain why the battery endurance did not last for 126 days. These are just handy to have on hand, and then you know who the operator was, so you can go and talk to that person if something looks odd in the data. Okay, so that's the deployment wizard. Because I configured this for autonomous sampling and I set it to not transmit data in real time, once I finished the deployment wizard, it commanded the MicroCAT to go into standby mode, waiting for that date, I think December 15th, to start sampling. At that point, if we were to take this HydroCAT, put it in the closet, and then forget about it, it would start sampling on December 15th by itself and be writing that data to the memory. So alternatively, if you were to put it into the water, it would start sampling at that date. Because it goes into that standby mode, it disconnects from UCI. And so if we want to do anything else from within UCI, we can click on the connect button. And it's going to tell us a couple of things. So same thing, baud rate, COM port. Once UCI tries to connect to this HydroCAT EP, it's going to say, hey, this HydroCAT EP is currently logging data or is waiting to log data. If you proceed with this, it's going to pull it out of that logging state or that standby state, and you'll have to redo the deployment wizard. So if you don't want to do that, you click on disconnect. UCI will just fail to connect or choose not to connect. If you click on connect right here, UCI is going to connect to your instruments and pull it out of the logging state. Now we're sort of back at square one. You'll need to repeat the deployment wizard before you disconnect from UCI. Otherwise, the HydroCAT EP will not log when you expect it to. Okay, great. Now we also have the option to just look at some data within UCI. I've disabled real-time output, so that's going to re-enable it. And then because my sample interval is 910 seconds, it's going to say, hey, you're going to have to wait a while before you get any data. So we can set our sample interval to something shorter, but instead, I'm just going to ignore that and click stop. If we were to leave this for a couple of hours, we would see data populate this time series graph right here. And then finally, within UCI, we have the option to transfer data off of the instrument memory. I don't think I actually have any data on this instrument yet, 0 samples. If I had some data on this instrument, it would tell you how much is there, and then you can transfer either all the data from the instrument into a single CSV file, or you can pick a range of sample numbers. Say you just want to look at the last week and a half of data just to make sure that your instrument is outputting something, is measuring reasonably correct. You can set it to say it has 5,000 samples. I know that encompasses a month. I might want to do sample 4,000. Just not going to let me do because there's not 4,000 samples. To say sample 5,000, just get the last bit to take a look at it. Totally up to you. I like to just upload all the data on the memory. Once you do that, your HydroCAT EP will upload a file with binary data with the .sbs.dat file extension, and then UCI will automatically convert that to a .csv file. That's just typical comma-separated values with a header written by UCI that shows some information about the instrument that was logging that data. So keep that in mind. These files are pretty easy to process, but if you're using maybe MATLAB or Python or something, just know that you'll have to parse through the header of the file. before you can spit out your data. Okay, so that's how you upload data. Pretty straightforward. It's pretty fast, pretty reliable. So that is UCI. I'm going to take a quick look to see if we have any questions before we move on. Natalie and Lindsay, are the questions all kind of squared away?
At this point, I believe they are.
Okay, great. Okay, if you have any questions about UCI, if I went too fast there, if you want to see anything else, please let us know in the Q&A. I'm going to close the software. And we will move on. So for pre-deployments, you're going to want to do a couple of things. First, run the deployment wizard, that wizard that I demonstrated in UCI just a moment ago. If you're using SDI12, you can also set the SDI12 address and flag, as well as the output string. All that can be done from within the deployment wizard. Before you deploy, install the pH module. If you want to get pH data, you can also deploy your HydroCAT EP with this dummy block installed. Obviously, you won't get pH data, but you still will get everything else. So that is an option for you. Don't forget to install the pH module, though, if you want to get pH data. An optional step that I highly recommend is to prepare the instrument's exterior for anti-fouling. Wrap it up in copper tape, wrap it up in electrical tape, just making sure not to cover the flow path. This picture on the right is actually a CFOX V2. It's just the best picture I had demonstrating copper tape. This works great for preventing biological growth on the exterior of your instruments. Okay, so we're going to do a mock deployment of our HydroCAT EP in this bath of warm water. I'm actually going to try to run the temperature check. I haven't actually tried this yet, so we'll see how it works. But first thing we're going to do is switch the camera. I have this bath of water next to me. Right here, and I have my highly improvised deployment pole right here with these clamps for the HydroCAT EP. So I am going to take this, let's do this, deploy these clamps. And so the HydroCAT EP has what's called a lifting bail on the top here. And you can tie a rope to this. I would not recommend deploying the instrument from the lifting bail. This is sort of a single point of attachment and is not going to be very secure for a long-term deployment. What I would recommend doing is using some clamps like these and attaching 2 of them to the body of the HydroCAT EP, like so, and then attaching the other one to your deployment pole, deployment cable. In this case, I have a broomstick that is effectively the same thing as a deployment pole. And securing these clamps to the body of the HydroCAT EP. Making sure both clamps are snug and your pole or your clamps are not going to interfere with the intake or the exhaust of the flow path. And you have 2 points of connection. Okay, so imagine that this broomstick is your deployment pole, deployment cable. We have 2 points of connection to our HydroCAT right here. This is a great way to deploy instruments. This is how I like to deploy it at our test sites. And going to take this bath of DI water. I need to move the laptop so my cable is long enough. And I'm just going to take this. And dip the instrument into the water. Now I'm connected to this in real time. My cable is connected, so I can actually fire up UCI. Connect to my instruments. And now I can click the start button if I wanted to log some data. What I'm actually going to do here is the temperature check. So the first thing you're going to do, this is going to tell you what it is, what you're going to be doing here. Next, I don't actually know the temperature of my water here, so I'm going to have the instrument measure it. Say, so when you do this, the instrument is going to start measuring the temperature and comparing it against your expected value here. So after this runs for a little bit, and I would recommend doing this in water. You can do it in air, but because air is less likely to provide a stable temperature, you might not get reasonable values and it might fail the temperature check. Okay, I don't know why it's not working. So we might not actually do this part. Okay, so I'm sending a pulled sampling command just to take a look at what the current temperature is of this water. The TS command takes sample. Oh, and it's because I configured my HydroCAT not to output data in real time. Okay, I might have to do some troubleshooting here, but anyway, oh, here we go. Okay, temperature 20.7261. That value might change. So in the interest of time, we won't go through the full temperature check. My instrument seems to be responding pretty slowly right now. But if you were to do this, I would recommend doing exactly what I did. Put your instrument into a bath of water, type in the expected value here, click start. Your instrument is going to compare the output from your HydroCATs to the expected value you type in here, and then make sure that that stays stable over the course of a couple of minutes or so. If it does, it's going to say your temperature check passed, your temperature sensor is working as expected, and then you can move on to a different check. But in this case, I just wanted to demonstrate a good way to physically deploy your HydroCAT EP using clamps like that, always using 2 attachment points. Okay, so post deployments, a couple of things you're going to want to do is flush the pH module remove the pH module, store the pH module into the soaker block with potassium chloride solution, and then clean the externals of the instruments. We don't recommend necessarily scraping off barnacles with a metal tool. You can damage your instrument that way. What works if you have a lot of barnacles, some calcium carbonate growth, is to take a t-shirt or a rag soaked in white vinegar. And then after that, let it soak with that. Don't submerge the instrument in vinegar. Don't soak it in hydrochloric acid or anything. And wrap it in the t-shirt or rag. And then after 10 minutes or so, take a plastic putty knife and then just carefully scrape stuff off. You can also use a Brillo pad to pull off any algae or anything. This picture on the right, I think, is really awesome. It shows how effective that anti-fouling cartridges are. The intake and the exhaust of the instrument, totally free of biological growth. The inside of the instrument, totally free of biological growth. But obviously on the outside, there's a lot of biological growth going on in the water. So in this case, anti-fouling cartridges worked really well. Okay, so I'm going to take my instrument out and put it into this bucket and demonstrate how to properly remove the pH module from your instruments. Okay, so when you get your instrument out of the water, imagine that this is dirty seawater. It's going to be wet. It's going to be covered with seawater. The flow path is going to be full of seawater. And I'm actually going to pull off my connector, clean that off later. The dummy plug for safety. So say I just pulled my instrument out. I would probably take off these clamps first just to make it a little more easier to move around, but I'm going to leave them on for now. Pour out any water from the flow path. Then now I want to remove my pH sensor. We have built in this new feature into the HydroCAT EP V2 where to prevent any seawater from contacting the pins on your pH sensor, we now have this little flushing port where you can flush it out with deionized water or clean fresh water, so that when you pull this out, any water that contacts the sensor is going to be clean fresh water, not potentially corrosive seawater. Your kit will include the syringe with this little piece of yellow tubing. I have my little cup of DI water here, so I'm just going to fill up this syringe. Set that in there. Now, inside of the cell guard, might be kind of hard to demonstrate on the camera, but underneath the second hole from the top, there's a little screw here that I'm just going to remove, and then that allows me to access the flushing channel. So I'm going to loosen this through. Pull it out. It comes out just like that. And now we have a clean pathway going from the outside of the HydroCAT EP through the flow path to where the pH sensor connects. So I filled my syringe with deionized water. I'm going to take this yellow tubing, insert it there, hold it in place, and then just push it through. I can see DI water leaking out from beneath the sensor. That's good. That means that any water that's around the pH sensor is now clean, deionized water. I'm just going to do that one more time. I'd recommend doing it at least twice. It's an easy process. Okay, so I've poured the seawater out of the flow path. I've flushed the pH sensor area with deionized water. Now I'm safe to remove it. Any water that's on the connectors will be clean DI water, much less likely to damage the sensor. Okay, so I'm basically just going to do the reverse of what I did before when I installed the pH sensor. Loosen each of these screws one at a time. And once they reach a certain point, I can just back them out all the way. And then take the sensor, pull it straight out, shake off any water, and then just take a moment to inspect it. Actually did pretty good this time, so there's not really any water around the connector, but if there were any water on the connector or the pins, that's going to be this clean DI water that we just flushed through the system. Now I'm safe to take this and put it back into the soaker block. I also want to make sure to inspect the connector inside of the HydroCAT EP. Take a lint-free wipe, like a Kim wipe or something, and then just dry out that area. If you have access to it, I also recommend taking a can of compressed air and then spraying that into the connector area just to get rid of any water. If you really want to make sure that it's safe, you can also take high purity isopropyl alcohol and use that to displace any seawater that's on the instrument. Okay, so again, I'm just going to reverse what we did before, where I'm taking the soaker block and installing this pH sensor. So the first thing that I like to do is remove the screw that blocks off the reservoir to the potassium chloride spot. Okay. Take that out, not lose it. And then I'm going to ensure that my connector is clean, make sure that there's nothing bridging the O-ring, make sure that it's dry. And I'm going to take this, insert it into the soaker block like that, and then I'm going to carefully screw this in place. Again, gently twisting it between my fingers until it's snug, and then tightening it just until it's snug, making sure not to over tighten. Now what I can do is turn this on its side like that, take the bottle of potassium chloride that we supply with this instrument, install this lid that has this little dispensing knob right here, and then pour that into this hole here. Now I'm pouring it in until it's kind of overflowing. We can see some of that solution over the top. That's okay. When I take the screw, put it in place, that's going to displace any of the solution. Screw this back in. And then I'm just going to inspect this, turn it upside down, make sure I don't see anything leaking out of it. And this sensor is ready to store. I recommend storing it upright like this. That way, none of that potassium chloride is going to leak out of the system. Okay, so in terms of maintenance and cleaning, there's a couple of things that you want to do. There's flushing the system with clean, fresh water and catching the effluents. What can happen in high biofouling areas, in high sediment areas, is that sediment can build up in the HydroCAT EP's body, and you might see some weird signals in your dissolved oxygen. If you flush out the system, I recommend pouring the effluent from the flushing procedure into a bucket or something and see if any sediment comes out. If it does, that would explain why your dissolved oxygen is unusual. That just gives you a good clue for troubleshooting your data. And then also, you can clean the connectivity cell and the dissolved oxygen sensor with a Triton X solution or run through the checks. In the event that you left your pH sensor out to dry, you can replace the pH reference junction on the sensor when necessary. There's a procedure for how to do that in the manual. It's pretty rare. In most cases, if your sensor was left out to dry for a significant amount of time, it probably needs to be serviced at Seabird anyway. So this is something you might do if you can't calibrate the pH sensor. In UCI, the calibration process continues to fail. You can try replacing the pH reference junction. We include all the parts in a procedure for doing that. We're not going to cover it today because we don't have that time. Okay, so the very last thing I wanted to do is demonstrate the cleaning and flushing procedure. And actually, one thing I forgot to do was reinstall the dummy block for the pH sensor onto my HydroCAT EP. So I'm going to inspect the connector, make sure that it's clean and dry, and then take the dummy block, install it into the body, and as with the pH sensor, carefully tighten it down making sure not to over tighten these screws, getting it just snug, and then wiggling it back and forth to make sure that it's properly in there. Okay, now I'm going to demonstrate the flushing procedure, but the cleaning procedure is very similar. We have some videos for how to do this on our YouTube channel. Basically, what you're going to do is take this syringe that's provided with your HydroCAT EP, where you have your syringe, this piece right here, this smaller piece of tubing that connects to this plastic piece to the larger piece of tubing that connects to the hose barbs on your instrument. Pretty simple. You're just going to fill this up with clean, fresh water, clean, deionized water. Put this onto one of the connectors here. And then often you'll want to take another piece of tubing that I don't have handy. And put this onto the other side, just so you can get a good head of water on the intake and the exhaust. And then you're just going to push this through the flow path, watch the water travel up the other tube, and move it back and forth. See if you see any sediment being stirred up. See if anything is coming out. And just use this to agitate the water in the system. Once you've done that a few times, you can pull off both. Take this, dump out the water, and then check to see if there's any sediment that's coming out. This is a brand new HydroCAT, so there's nothing coming out. If you want to clean your instrument, what you can do is take some 1% surfactant solution. So this can be Triton X, Turgitol, basically a scientific grade detergent is what you want to use. 1% detergent, 99% deionized water. And then do pretty much the same procedure where we're filling up our syringe with our cleaning solution. And then we're installing the hose barbs, the tubing here. And we're doing the same thing. We're going to move it back and forth, and you'll see the bubbles forming. Just do this for about 30 to 60 seconds or so, agitating anything in there. This is going to remove any oil, any biofouling that may have found its way inside of your flow path. And then remove it, dump it out. And then repeat this process with clean deionized water to get rid of all the soap. Once you don't see any bubbles coming out of the other tube, you know that you've removed most, if not all, of the cleaning solution, and your instrument is ready to deploy. Okay, so that's pretty much what we've got for training today. We covered a lot of material, so please hit us with any questions in the Q&A, and we'll use the last 10 minutes to answer those.
Greg, I think the majority of the questions have been answered, so I don't know if you just want to speak to them verbally, but they're published in the chat.
Okay, awesome. Natalie, while I'm catching up on the Q&A, was there anything that you wanted to address in these questions?
No, I think mostly they're very good questions, and a lot of it is configuration dependent. So as we mentioned earlier, the HydroCAT EP has a lot of optional modular sensors that you can choose to have with your deployment setup. So a lot of the questions in terms of like the pump timeline, the sample interval, is highly dependent on what you choose to use. So the oxygen sensor, for example, flushing is recommended, and then the turbidity and chlorophyll sensor at the end of the instrument takes some time to actually open the shutter and use the biofouling wiper to actually clean the lens and then take that sample. So a lot of it's going to be dependent on what you're choosing to work with in terms of your equipment setup. Obviously, these are good questions that we are more than welcome to help you with when you're making those decisions. So we have our technical technical support team as well as our technical engineering sales team that are here to support you. So please don't hesitate to reach out to our teams. I'll throw those emails in the chat for you if you have specific questions about your configurations. And some of these questions can also be answered in our manual. So we have some really good information on the decision-making process and what some good questions to answer while you're deciding what sample interval, what cleaning interval, and how long you'll be deployed. So please take advantage of those resources as well.
I'm also including a link to the HydroCAT EP V2 landing page on our website, which hosts our data sheet, a comparison overview of the differences of the V1 versus the V2, as well as some links to some of the videos that we've created where Greg outlined some of the processes that Greg actually facilitated throughout this video. So I'm linking that in the chat, and feel free to check it out if you want to circle back on any specific points or procedures done throughout the training. And I'll also be including a link to a survey that we have. And basically the survey just enables you to request if there's any specific type of training that you would like to see through Seaberg University in upcoming sessions. So whether it's product focus, application focus, we'd love to hear your feedback to see how we can better create sessions around issues or challenges that you may have. So please feel free to fill that out. We'd love to hear from you. And I'm linking that in the chat as well right now.
Okay, we've got a couple new questions coming in. One of them, if you have a bucket of water for testing, do you recommend clean water with purchased salt in it? I'm going to assume that by purchased salt, you mean table salts, NaCl. Yeah, that works out great. My bath water that I've got right here that we did our mock deployment in, this is actually just deionized water. There's a sign on this bath that says it was cleaned on 8/6/2019. So I don't know. This is maybe actually a really good representation of a gross biofouling environment. It looks pretty clean to me. But you can use fresh water. You can use fresh water that has salt added to it if you want to maybe test your salinity. If you really want to, what we do here in some of our test baths, not our calibration baths, is we will take the volume of water in the test bath and then calculate how much salt we need to add to that. It's usually an enormous amount of salt. And then that's a good way for us to just quickly say, is the conductivity sensor on this instrument working? We expect this to be around 30 PSU or something. And then so we can put the instrument into that bath with a bunch of dissolved table salts. And then sure enough, it'll usually tell us 30 PSU. That's a good way to check your sensors just to make sure it's outputting a somewhat reasonable value. Not a good way to calibrate your sensors. That requires a much more precise methodology. Please let me know if I didn't properly answer your question. Okay, we have another question. Can the pump be disabled for certain applications, such as profiling CTD deployment, so that I can get quick sampling for CTDs only? The HydroCAT EP is not a profiling CTD. If you try to profile with this instrument, the data you get from it will not be good. This is designed to be a moored multi-parameter instrument. If you're using it as just a CTD, it's designed to be used as a moored CTD, not to be moving through the water column, not to be exposed to really dynamically changing values in space. The flow path on the HydroCAT EP, as we saw early into the presentation, is this U shape. Here, let me share the. And so this U-shape really depends on the pump. It's pulling water into the intake, past these sensors, and then pushing the water out through the exhaust. If you're profiling with this, because it is shaped like a U, your water is not going to be able to enter this very easily at all, especially when you have the anti-fouling guard in place. And so you really need to use your pump with this instrument. It's designed to be used with a pump, what will probably happen if you disable the pump, which you can do by turning the minimum conductivity frequency up to 1,000,000 hertz or something. I don't recommend doing that. You'll probably get seawater into your plumbing here, and then all of the samples after that will be of effectively that one parcel of water that's currently in the plumbing, because the pump is not replacing it with new water. So do not use this for profiling applications. It's designed to be used for moored applications. So that is my recommendation.
One last thing I'll add is that this training will be uploaded to the HydroCAT EP V2 page on our website, as well as to our YouTube by the end of the week. So if there was anything specific from this training that you wanted to revisit, it will be uploaded there for you to check out.
Yeah, I'm seeing some notes that the resolution of the screen was kind of low, so I apologize for that. That might be a limitation of the this Teams Live platform we're using. Hopefully the video that we upload has a better resolution, but if not, we'll try to just record the specific things that we showed in UCI today, and then we can upload that for you to get a better picture of how to use the software. We apologize for any issues with camera or screen resolution. Okay, well, we still have a few minutes left. Feel free to send any questions our way. We'll be around to answer those. Right now, in the meantime, I'm just going through and getting the rest of this cleaning solution out of my HydroCAT EP. I've flushed it out.
Greg, I'll take a minute to comment on the process of upgrading to V2. So we have a good question in the chat. So yes, so this is the newest version of the HydroCAT EP line. In order to upgrade, they are upgradable. So when you send your HydroCAT EP V1 in for service and you fill out an RMA form, there will be an option there for you to opt in to upgrading that. This upgrade is completely free. We're encouraging people to do this upgrade because we believe in the V2 version. So simply pull out an RMA for your instrument and send that V1 in, select the V2 option, and we will go ahead and do that. What will happen with the V1 instrument, the V2 is backward compatible with the oxygen sensor, so we will utilize the same oxygen sensor from your V1, as well as the HCO, which is the turbidity and chlorophyll sensor, if that's the option that you have. The pH module itself is not backward compatible, so what happened when we redesigned the instrument is that the form factor of that module changed a bit, so it no longer fits in the V1. So we will be replacing the pH sensor from the V1 instrument with a new pH sensor when you'll get back the V2 instrument. But otherwise, the instrumentation in terms of that optional oxygen and HCO will be the same at which you have sent in to us. So that is the option for choosing to go from the V1 to V2. We are also no longer selling the V1 HydroCAT EP, so all future purchases for new equipment will also be the V2. So you're highly encouraged to work through transitioning to the V2 instrumentation. And again, I've elected to do that for you free of charge when you have your next service. And our service team is more than happy to offer some more information about that process if you need to have some additional details. Once again, I think I'll speak for both Greg, myself, and Lindsay and say thank you for joining us for this special session. Again, we have many resources online, and we will continue posting more of this information throughout the week for additional help. Please don't hesitate to reach out to our sales team and our support team for more information as well. But from all of us here in Seattle, thank you for joining us, and we look forward to seeing you next time. Thank you.
Yep, thanks everybody.